Good afternoon, geometry periods 3 and 4. It's Wednesday, the 13th of May. It's Maze coming at you from room 308. How are you today? Well, I hope you're all phenomenal. Today I would like to give you a little insight into some inscribed angles. Problem number 39 out of 11 point something, 11.2 maybe. And then the segments of secant's theorem. I'd like to go over that a little bit, all right? So first, I really want to clear up this concept of an inscribed angle versus its intercepted arc. So let's look at that first. So here we go. I have a circle. It has an angle measure. It has an arc. Notice that if the angle is 100 degrees, the intercepted arc is 200 degrees. So the measure of angle BAC, if the measure of the angle is 100, the measure of the arc is 200, all right? Now here's the other way around. If you start with an arc of 300, then the measure of the angle is 150. The measure of the angle is half the arc. So if the measure of the arc is 300, the measure of the angle is 150. Okay? I really hope we can get that squared up. That's going to be very helpful for you folks, all right? All right, next time we'll look at the segments of secant's theorem. I think this is on page 571-ish of your book, somewhere in that neighborhood. And it tells you that if you have a circle, and you have a point outside that circle, and you draw a couple of segments, secants, okay, that there's a relationship between the four segments created. I have four chunks, all right? If you look at this, I have piece AB, I have BC, I have AD, and I have DE, all right? Now, we all remember from the segment addition postulate that if you take and add 2x plus x plus 1, that gives you the entire length AC. If you add 3x and x, it gives you the entire length AE. All right, so we need that to make this theorem work. All right, so basically the theorem says this. It says that if I look at the two secants, the part on the outside times the whole thing is equal to the part on the outside times the whole thing. So let's see what that really looks like. So let's look at AC. The part on the outside is AB. So that AB times the whole thing times AC is equal to the part on the outside, AD, times the whole thing. So this piece out here times this whole thing is equal to this piece out here times this whole thing, all right? That's what that says. Now, I chucked some numbers up there. So AB is 2x, and BC is x plus 1, and AD is 3x, and DE is x. So how does this game play out? The part on the outside, 2x, times the whole thing, 3x plus 1, is equal to 3x, the part on the outside, times the whole thing, 4x, okay? So 2x times 3x plus 1 is equal to 3x times 4x. Clean that up. 6x plus 2x after we distribute is equal to 12x squared after we distribute, okay? So 6x squared plus 2x is equal to 12x. Set it equal to 0 and solve. This is easy. 0 is equal to 6x squared minus 2x, subtracting 6x squared from both sides and subtracting 2x from both sides. Factor and solve. Well, take the greatest common factor. It's the first thing you do when you factor. You always look for a greatest common factor. 2x times 3x minus 1 is equal to 0. Well, the first factor, 2x is equal to 0 or x is equal to 0. The next one, 3x minus 1 is equal to 0. You know the drill. You add on 1 and divide by 3, and x is equal to 1/3, okay? So if you were to plug those in, you get 2/3 plus 4/3. That would be the whole length of that one, and then 1, and then the DE would be 1/3, okay? All right, now, let's look at problem number 39. I think this is at 11.2. I don't know if it was assigned or not, but boy, I could have a lot of fun with this problem, okay? All right, so this is what you're given. You're given a picture that looks like this, okay? It says the radius of circle A is 3x, the radius of circle B is x, and the radius of circle C is 5x, okay? Now, they want the length of AC. And they tell you that if you take all three circumferences and you add them up, you get 63 pi. So the sum of the circumferences of circles A, B, and C is 63 pi. Find AC. Well, what I did, I came over here. I said, you know, if the radius of this circle is 3x, And this is another radius. Well, this also has to be 3x. If this radius is 5x, then this radius must be 5x. So the entire length of AC is 8x. I just need to solve this thing for x. That's all I have to do. All right? So how do you do that? Well, if the radius of circle A is 3x, the diameter then is 6x. If the radius of circle B is x, the diameter then is 2x. If the radius of circle C is 5x, yeah, you can guess it, the diameter of circle C is 10x. How do you find circumference? Diameter times pi, 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 diameter times pi is equal to 63 pi. Add them up. 18x pi is equal to 63 pi divided by pi. 18x is equal to 63, and x is equal to, wait for it, 7 halves after you reduce that lovely fraction. So x is 7 halves. Well, if AC is equal to 8x, 8 times 7 halves, 28. The length of AC is 28, okay? Now what I did is I filled the rest of them in, okay? And I got the dimensions of this triangle. Isn't that a thing of beauty? Now this is where I'm gonna get you, and I didn't do that angle. I chose to do this angle instead, okay? I'm gonna say, okay, now that you have that, I would like the degree measure of all angle A, B, and C. And then I want the area of the sectors created by A, B, and C. And that may be my final question. What is the sum of the sectors given that problem? Wow, to do that, you need to find what x is, because you need some radiuses. Then you need to find out the areas. Well, to do that, you need the angles. To get the angles, you're going to have to use the law of sines or the laws of cosines. Isn't this a cool problem? All right, so how do you find the measure of an angle? You found the length of the sides of the triangle. All you have is sides, you have no angles. This means the law of cosines is to come into play, all right? I'm going to find the measure of angle B, all right? So the law of cosine says that B squared is equal to A squared plus C squared minus 2AC cosine B, okay? So I plugged the numbers in there, I did my squares, and it comes down to the measure of angle B is equal to the arc cosine, or the inverse cosine of 147 over negative 588. Okay, you punch out your calculator, and the measure of angle B is 104.47 degrees. Okay? And now you can find the area of the sector of circle B. And now you can use the law of sines, because now you know that this is 104.47 degrees. You can use that to find the measure of angle A or C and then subtract from 180 and get the other one. Then you can actually find the area of the sectors. And you can add all those up and you can tell me that. So you can imagine what a cool question that would be. I could say, given the circles, the sum of the circumferences is 63 pi. Tell me the areas of the sectors. You'd have to do a lot of work for that, wouldn't you? And then I could throw some L's in there. I could almost build half a semester test out of that one problem. Anyway, I like it. I think I'm going there. Pay attention. All right, so now you have a little preview of some devious stuff I'm coming up with to write a non-standardized semester test for you guys, because that's our direction, is a non-standardized test. Anyway, that's kind of where I'm looking. So I would pay attention to problem number 39 out of whatever section that is. And anyway, get a grip on it. All right, that's all I got for you. May's out.